In this video, we're going to do an example that uses Bayes' theorem. So let's say we have a university where the student population is made up of 35% freshmen, 30% sophomores, 25% juniors, and 10% seniors. At the end of each academic year, prior knowledge tells us that the probability that a freshman does not return in the following year is 0.2, that a sophomore does not return is 0.25, that a junior does not return is 0.4, and that a senior does not return is 0.1. Let's suppose that we randomly select a student and know that that student drops out or does not return. What is the probability that that student was a sophomore? Again, in the prior year. So let's just, for simplifying the notation here, let's just say F is freshmen, S is sophomores, J is juniors, E is seniors, and R represents does not return. We are asked to find the probability that the student was a sophomore given that the student did not return. Using our conditional probability formula, that is the probability that the student was a sophomore and did not return, divided by the probability that they did not return. So here's where Bayes' theorem comes in. We can use our conditional probability formula to rewrite the intersection on the top. We can basically flip the conditional around, if you will. So we can rewrite this as the probability of being a sophomore, and then times the probability that the student does not return, given that the student is a sophomore. We have that information given to us because we know the probability of being a sophomore is 0.3, and the probability of not returning, given that the student is a sophomore, is 0.25. We need to rewrite the probability that they do not return into something that we know the values for. Well, there are four ways that a student could not return. They could be a freshman and then not return. They could be a sophomore, then not return. They could be a junior, then not return. Or they could be a senior and do not return. Those are mutually exclusive events, right? Freshman and not return is mutually exclusive from sophomore and not return, and so on. So we could write those intersections as a sum, and then rewrite the intersections as in terms of the conditional probabilities. So, again, the way that you could not return is be a freshman and not return. You could be a sophomore and not return, junior and not return, or senior and not return. That's what we're saying, or, that's why we have plus signs in the middle. And again, these are just using the conditional probabilities ideas in terms of rewriting the intersections, if you will. All right, and so now we have all of these values. So this is what the next line is, just plugging in all those values. And if you simplify, you'll get a probability of 0.294.